Bye.
Okay, good afternoon. This is the second part of the tutorial about geographical information system. And this morning we explored three tools, meaning QGIS, which is an app that runs on the local computer. So we talked about a local application. And the other two tools are run on the web. One is OpenStreetMap, which is in fact a service that allows people, crowd sharing, that allows people to record points of interest with characteristics on a map in order to make them available to others without restrictions. And next, finally, we have seen the main characteristics of UMap, which is instead a system that allows the users to create own maps and have restrictions on people that may access to it. This gives a lot of possibilities more, because we do not interact, the user does not interact with one common map, but each user may have his own map with the features and the background he likes, and share it with the people he likes. The next tool we are going to explore is, in fact, it belongs to a class of tools, is one that allows getting uh, coordinates and geographical informations while we are on the field. We presently have a relevant service, a very important service, which is the GPS, the Global Positioning System, that allows, in a straightforward way, to know where the user is, to know the position of a device. This is important because before the GPS, we had to do complex calculations and observations in order to define exactly the place where the user, the observer, is. Presently, with the GPS, we can do nothing. We have to do nothing. We simply observe that we are at longitude, latitude, such and such. This operation is completely automated, and we can imagine that instead of having a user that goes around and records images and position, we might have automatic systems like drones and such that make exactly the same, except that there may be much more automatic devices, and they cost much less than human beings to be sent around. So the architecture of the system is now a bit more complex. You remember, at the first stage, we had a single user here. The second stage, meaning OpenStreetMap, we had the user with a single map available and shared with others. And the third step, we had many maps individually accessible by many users. And here we have a new character in the play, which is the user that is on the field. The role is different because they are using geographical information. They are users of geographical information. This user produces geographical information in terms of land, longitude, latitude, and things that are observed in that place. So we have now a new role. And this role is enabled by technology, because now we have the GPS, now we have devices that are sufficiently powerful and portable that we can carry around and take pictures with the coordinates on them. Okay, can be replaced by autonomous devices, I told you. And there are really a lot of such devices. And but I found one that may be interesting for us, which is the Gaia GPS, which has the advantage of running on both Android and iPhone, so that we in the scenario where we are all in the same room, we could make a lecture with the same tools in this settlement. It is pretty different, but anyway, it is always an advantage to be able to refer to the same interface and behavior. You need to register to the service if you want to use it. It is free. With some limitations, but you can use a free account that gives you a lot of possibility anyway. And at this point, you can do a number of things that are different from those we were able to do with the other tools. For instance, record a live track of an itinerary. This means that I walk, and while I walk, my data are recorded and kept inside a memory. It is in fact a multi-line feature, sorry, multi-point feature. Anyway, I can record waypoints or points of interest, which means points where I have something special to record, observation or whatever. These are recorded as point features in Gaia specifically. I can write something about the places I visit. When I am on a waypoint, I can write an annotation, or I can take pictures where I stand and where I record a picture specifically. So I am able to document, to have a very detailed documentation of a movement in my space. The detail comes from the fact that I have coordinates of the place where I am, and the user can add information to the plane coordinates that by themselves are not so useful. Gaia GPS allows to perform all such activities, and once you have recorded your track, you can export it. And the standards are those that I already told you. GPX, which is specific for GPS devices. KMZ, which is the standard from Google Maps, or plain CSV, which are a passepartout which is understandable, but in any way. There are two sides of this service. One is the application that is running on the phone, which is called Gaia GPS. And there is another phase of the same service which runs on the computer. On a computer, we have a wider interface. We have a larger computing support with better CPU, with more storage and all that. So there are these two facets of the work of the tool. On one side, the smartphone; on the other, the PC. And the two communicate smoothly without much effort one with the other, using data that are kept in the cloud, in a cloud that is specific for Gaia GPS. These are the screens, the relevant screens of the Gaia GPS application. This is the landing screen. Landing screen, which represents the place where you are. You can move the representation, but when the app starts, you are the screen visualizes where you are at that moment. And while you move, a line is traced to show where you passed. These markers are waypoints, the places where you marked something relevant you took a note or such. In order to start your recording, you press on this on the touch screen here. Record, registra in Italian, and the recording starts. You have to nothing more to do. Just one touch and the recording starts. The recording will consist of a series of points, a very dense succession of points, each one with a specific coordinate. The coordinates, of course, are taken from the GPS service. While I am walking, I can do a number of things you see here. Recording, add a waypoint, corresponding to my position. Here I have the screen in Italian, of course, because my phone is in Italian. And so important here is the possibility to take a snapshot, a photograph, and so you can take this kind of associate this kind of information to the points you visit. This is obtained with a plus sign here. This is used to center the position. This enlarges the screen. This is used to find things. And the relevant thing here is this saved touch, which brings you in the list of tracks that you have saved recently in your history. When you save this, everything goes in the cloud storage of Gaia GPS. So this is persistent. It's not simply on your phone. And this adds a great possibility, because in this way, without much problems, in a straightforward way, you save your work, your trace or your track in the web, and you can later process all this using the web service. Here are the operations that you can perform. Start recording with the record button here, registra, and record waypoints and take picture using the plus button, right screen I've shown you. You can pause if you do not want to keep on your map some kind of detour that you make. You can pause and resume, terminate and save the track in the end. You can export, of course, in various formats, and as I told you, one is GPX, the other KML, and finally comma separated values, and they are ready to be shared. The other facet is the Gaia GPS web service. You reach it using this URL, And as I did previously, I will switch and show you what you see on the screen. Right? The place you see is in Abruzzi. And I move my map to Pisa, where I have some saved items. Here are all the items that I have previously saved in my in my cloud storage. And in principle, even if these slides are 2 years old, you maybe might even find this. I'm not sure. Let's see. It takes time to download. Sorry. Sorry, but they do not show up. I do not understand why. I can reload. Okay. And I was about to look for the same tracks you saw on the slides, which means, for instance, this one recorded on June 5th. This one. Yeah. Might be this one. This is the appearance of the tracks I have already recorded. And once I have them on the screen, here you see on the slides, you see a different track, but the idea is exactly the same. You have a trace of the track, and you can export the various representation of this track, and you have also limited possibilities of editing the same. You can add a waypoint if you like, and similar things. We can do a simple exercise which consists of importing a GPS track on QGIS. I go back to the slides now and show you the easy steps to obtain this result. For this, you have first to download your cloud data. You have to download it on your computer. And once you have them on your computer, you can do the following operations. You open QGIS and create, of course, a new project, or you can use the old one and add a new layer. And in this layer, add a new vector. This is the kind of operation we did before. In this case, we add a new layer, and we specify that we want to to add a vector layer. At this point, we are offered the possibility to navigate your hard disk and find the place where you placed your GPX file, the one you downloaded from Gaia GPS. Now you simply add, and you have your track recorded on QGIS. And now you have a lot of possibilities to work with this data, much more than you had on the QGIS, on the Gaia GPS tool. It's okay. So we have the possibility to record, to have a live record of our walk movements, record them in the cloud. When I am back home, I can download this data and re-upload to QGIS. And at this point, I can do whatever I want because QGIS is extremely powerful. And this is coupling at least 3 technologies. Because we have first the service, the smartphone application that runs on a service specific for this kind of applications. From there, I can move my data on a cloud storage, and from the cloud storage, I can import it into a web application, which is Gaia GPS. Using Gaia GPS, I can download my work on my computer and use it using a local application, which is QGIS. So you see that the game is more complex, and we have several tools that are useful, that contribute to this operation. And it is important to find, to select the right tools for this. Otherwise, things may become extremely complex. Which is the critical point in all that, because there are many tools, all extremely sharp in what they are designed to do. Okay, but this is the case where I want my map to be available on my computer in order to reshape my data using QGIS. But assume that instead I want to share this information with friends without being limited to the conditions under which the material is made available using Gaia GPS. In that case, it may be better for me to upload in UMap, to upload my data in UMap. This is a free service, so I'm not linked anymore to Gaia GPS, which is not free, for instance. The game is almost the same. That is, I download the data using this operation here. I download as GPX, which is the most useful for this task. And I go to the UMap web service. I upload my map using the import button on the right. I can upload my file. And finally, my track appears on UMap. Different game, but with a small difference regarding where is the final destination of my data. In one case, I wanted my data to be on my computer to reshape it in any way. In the other, I wanted my data to be available on the web in order for other to have access to it, to see it. I can comment the waypoints I recorded with photographs, images, and whatever I want. Okay. Questions? At this point, as I told you before, there is the possibility to try a challenge. Is not so challenging, but anyway, it's maybe more amusing than challenging, and try to track a walk. If we had half an hour, but we do not, you could go outside with your phone and take a small, short walk, record your path, go back to your computer, and publish using the way I've showed you before. Publish it using UMap in the same map we used previously. I don't know if it is no more visible. Okay, guess this is not possible, but you can go in the data that I provided you, and you will find there many tracks that I have recorded in the past. So I leave you another 10 minutes or such, at least to go and see what is available. Next, if you are sufficiently curious, open UMap. Subscribing is not complicated, and try to upload one of these tracks that I have made available on the web service. So I leave you 10 minutes to do that, and next we continue with the next step, which goes back to QGIS in order to see how to georeference an image, a JPG image. Okay, see you later. But anyway, I remain here and listen for questions if there are any. Okay, I actually don't know what happened. And if you received my last words, that is, can you hear me?
Yes.
Okay. And did I reach the end of the lecture during because I lost my contact, but I have not noticed exactly when. So did I finish my previous talk or not?
Yeah, you finished everything.
Okay, good. Sorry for that, but again, I lost. I don't know, but I lost my contact with Microsoft Teams. Okay. I left you some time to try to access the material that there is in the repository. Any question or anything else about this? Otherwise, I proceed. With the next section. Okay, we are speaking about georeferencing. Georeferencing is a quite complex operation that is useful to take a map in the form of an image, of a JPG image, and turn it into a raster. A raster can, after that operation, the raster can be used to place other layers on it and be used as a basis for further work when, of course, geography is important for this work. This is what I just said. How do we do this work? This operation is carried out by taking the image and giving coordinates to a limited number of points in that image. I consider that that image has a kind of geographical meaning. That is, I know what is the meaning of a number of points. Meaning means the coordinates of these points. So I start from this map and I designate the coordinates of a little number of points. At this point, the tool that we have available, and QGIS is one of them, the tool is able to infer the coordinates of all the other points in our picture. And this is the final result that we want to obtain, because at this point we will be able to use this georeferenced image in order to make to do our work. In principle, only 2 points are needed. If we have a perfect map with the same projection, then 2 points are sufficient to superimpose exactly the map. But this is not always the case. More frequently, the image, the original image, needs to be morphed, that is, distorted topologically, in order to adhere to some kind of geographical coordinate system. A good choice for the points that I select as references, that is those for which I give to the tool the exact coordinates. Characteristics should be that these points are distant on the scale of the map and are not aligned, because otherwise my mapping, my georeferencing will be imprecise. Now, finding the coordinates of a point is always difficult. Because, for instance, if I have a point corresponding to a town, I can give the name of the town to Google and have as an answer the coordinates of this town. But this may not be sufficient to have a good georeferencing. So what we often do is to take a map that we know as being correctly georeferenced and associate points in the image that we want to georeference, associate points in this image to points, meaning cells, in the original, in the reference raster. In this way, our tool takes the coordinates from the raster and performs the same task that we have seen here. Simply, the reference is not taken by giving as an input longitude and latitude of a point, but comparing a map of which we know that the coordinates are correct. Not so easy to say, but you'll see it's not complex to do with the right tool. And QGIS can do that in a reasonably easy way. Let's see how to do. First, you create a new project as usual with a reference raster OSM, OpenStreetMap. This is our reference raster. We want to superimpose on this raster an image that we know is an image, therefore not georeferenced. We scale operation. We scale the map to reach the same scale of the image that we want, and we can consider the code. We already noticed that, which corresponds to the projection on the screen, which is the standard one to display a map on the plane. Next, we select raster georeferencer, and I switch because it is a little bit more evident to see this on the map. Now you should see OpenStreetMap, is it? We go to raster and georeferencer. We click here and we have a new window. We open as a raster. Well, in fact, it is not yet a raster. This is the image that we want to georeference. And in this directory, in the maps directory, where you will find a lot of images of this kind. But in the transparency, you find the georeferencing of this image. I would better do this one. See if it is okay. This is an extremely raw image of a piece of Italian coast that I will show here. It's the same coastline that I told you to work on during the. You see it as this one. This Monte Rosso is here. Porto Venere is here. Orientation is wrong because this is not north and this is not west. Maybe it is a bit distorted. We have very rough points here, but we want to try the game of georeferencing this image that you can download. You can simply scan from a leaflet. So I have opened my my raster. And I have to decide how do I want to make the transformation. Most of these informations are correct. You have to know to leave it as they are. This is the way the surface is morphed if needed. This is the kind of approximation. Okay, this one is important. This is the the projection, the coordinates we are using, and it is the one we have already seen during the introduction. This is an output raster. You see the extension is TIFF, which is not PNG, is not JPG. TIFF is much more powerful than the others. Oops, no compression, and I want to see the map when it has been implemented in QGIS. I say okay. Next, I have to do the work I told you before. That is, this is Monte Rosso. I have to associate to Monte Rosso a point here that corresponds to Monte Rosso, and continue with the game for 3 or more times. Here we have a very bad map, so it is possible that okay, 2 are not sufficient, but we will see what happens if we get only 3 points. So the procedure consists in finding a point here. You see I have a crosshair. I indicate Monte Rosso al Mare. This dialog asks me for the coordinates. This is the complex way of doing things that I anticipated during the explanation. But we do not know the exact coordinates of Monte Rosso, and we do not want to go and look for them. We obtain the coordinates from the map canvas, that is from our reference raster. So I click here, everything disappears, and I have my crosshair ready to tick on Monte Rosso al Mare. These are the coordinates that have been recognized. Consider that they are not longitude and latitude, because they are coordinates that are mapped in this way. And I say OK. And I have a line here for Monte Rosso. Now I take another Manarola. Same steps. Manarola is here. And I say OK again. And I have my second point. And finally, I take Porto Venere, which is here. Map from canvas, and which is here. Okay. At this point, I have 3 points recorded for my georeferencing. Only 3. And I ask to QGIS to do the work. My map georeferenced will appear superimposed to this area. And the result is not satisfying, as we see. Why? Why? Because the map is very imprecise, and we have given only 3 points, not very accurate either. So the result is something that is completely useless. So we try to redo the work. And we want to first remove this modified thing. And next, take back this window to repeat, to continue the work. I add 2 more points. Vernazza. Okay. E Rio Maggiore. There are many reasons why these points are not satisfactory. There are many reasons why these points are not satisfactory. One is that they are aligned, and this is not good, and probably another reason of failure of our previous attempt. Now we have finished, and we are ready to redo the work. Hopefully, not a good result yet. Okay, what to do now? What to do next? Add more points and succeed in having a better, less alignments and more detail. For instance, I add only these 2 points, and next I give up. And the last one, we can take Corniglia.
The map in blue and white automatically rotates. And
yes, it should automatically rotate.
But it seems to me that it doesn't do.
No. The result is not satisfactory. But okay, I started from a terrific map, and I
so
did not.
The first tip is don't use a terrific map.
Yeah. But you can, but you must expect to have a lot of work to do. No, nothing. Sorry. Yesterday, I tried the same experiment with this map, and the result was at least of some interest. I'm sorry that in this case, nothing interesting happened. You can try again. I'll show you the result I obtained with something easier to work on. Here I have to remove this layer. And I used another map, which is this one. But I will not do the work right now, otherwise it's a loss of time. This map here, okay, there are already some points marked on it, and we can locate them. You see the red dots are the points that I found and and georeferenced. One is here, one is here, and another is here. The map should superimpose here, and you see the 3 points. Now I don't know if there is any interference with my previous unlucky attempt, so I'll try to see what happens. But anyway, better results are on the slides, and in the worst case, I will comment these results. And the map is here. Okay, this is the map I want to georeference. It should fit more or less here. These are the 3 points that I marked here. And if I do this, okay. Okay. You see the result is at least acceptable. We can double check our result by modifying the transparency. If we make our new raster transparent, we see our reference image underneath. It is now too transparent. Okay, you see here, these points are quite far from the points I selected as a reference. And you see that here there is a a difference. You see, here is the coastline for the georeferenced image, and here is the same coastline in the OpenStreetMap raster. And there are similar discrepancies here in the north. Lille is farther from the sea. And okay, just to tell you that with just 3 points, with using a reasonable map, I obtained a result that is acceptable. 3 is the minimum. Best is to select many. And you see that in this case, I used the 3 points that were sufficiently far and certainly not aligned. To have a better results, I could add other points that are far from them and maybe near to the points where I see a difference. And the software will manage to modify, to morph my coordinates in order to obtain a preciser matching. There is a difference also on the north coastline that is not visible here, but I guess this might be noticed using a different opacity just to have things more evident. It's okay. Here. Questions about this? Consider that now we could remove our old layer. Sorry, but I removed the wrong one. Okay, I could remove the OSM layer and work only with the new one. And this and this way I could effectively use the new map, the georeferenced map alone without the OSM support. Okay.
Can I make a question?
A what?
Can I ask something?
Yeah, sure.
Yes. I just wanted to ask if there is some kind of website or something like that when one can find already georeferenced maps, something like that.
Yes, there are places. Yes, there are places where you find this kind of data already present. Not so interesting from my point of view, because I want to teach you how to georeference your images. But yes, there are places.
No, of course, it was just to know.
Yeah. There are places like this. Yeah, there are places like this. I do not have references right now. I remember that in one of the first versions of this tutorial, I gave addresses for this. But okay, go on Google and find for georeference the images of whatever you like. Yes,
okay,
anyway.
Thanks, but it was really interesting. That's what I wanted when I asked before about using other images or maps. So okay. Thank you.
Okay. No, there is this here. Okay, we can hide OpenStreetMap. Yeah, no. This was the georeferenced image. And on this, we can add layers and do whatever we want. So any further questions?
Actually, I think that this tool is really useful, both for research and both for I don't know, exhibition, education, conferences. So it's very useful in order to show how some historical map could be empowered, no?
Mm-hmm. It may be useful to make connections between the places as we know them today and the places as they were time ago. For instance, in this case, I have superimposed to a map of France the old tribes that were living there, and you can, this way we can find which towns were in one area or the other. For instance, yes. But this is not the end of the story. And I go back to the slides because there is much more that can be done using QGIS. And now I go back to the slides. Oh, sorry, I have to retract where my presentation has gone. Okay, we are here. And it's not the end of the story because we can't do much more. For instance, there are many data repositories where you can find information, geographical information, for instance, in the simplest case, about the height of a place, the altitude. And others where you can find traces of recent flooding areas or earthquakes, whatever you have in mind. You can find such data recorded in a way that it is easily can be easily mapped using, for instance, QGIS. And here is a site where you will find many examples, tutorials, affordable and also accurate tutorials about QGIS. And other geographical data are available thanks to regional or global entities that publish this kind of data. For instance, you find here information that is delivered by the US government. And here you find a lot of information about Italy through the ministry. And okay, you can import this data that they are published in this case as WFS, so you can import them in QGIS using new layer and WFS. If you want, this working with terrain is exactly about the task of loading altitude of places, and is and it uses information, global information provided by Earth Explorer by USGS. Okay, to have an experience in using these tools. Okay, that's it. If you have questions or comments. Sorry that the first example that I did not end up as I expected, because the result was funny. The one I obtained was irrelevant and not funny, but maybe I can. Okay. Comments? Okay, I can again. Hello.
Break? What do you want to do?
Sorry, but I didn't.
Do you want to do a break or?
Yes, well, the usual break, 10 minutes. If you want to.
Only 10 or also 20?
No, I'd say 15 if you want more.
15. Okay.
Okay,
15
15
minutes. So 3:30.
3:30, and we have something interesting to look at after that time.
Okay. Good. I stop the recording.
The recording here. Okay.